Welcome back. So let's discuss the different hyperparameters we have for the random forest. First, we have the number of estimators, and we said this before. We discussed this before. We said that this is the number of trees in the forest, right? And then the criterion, this is the same criterion for the decision tree. So we have the Gini or the entropy, okay? The maximum depth, we also discussed this before. The minimum samples per split, this is also a decision tree hyperparameter. The minimum samples per leaf, this is also the same. Minimum weight fraction per leaf, this is also a hyperparameter coming from the decision tree. And here we have the maximum feature. We explained it in our implementation, right? So the number of features to consider when looking for the best split, okay? And for the sklearn implementation, it can be an integer, float, or string, and you can read the documentation if you want to know more about how you can use this specific hyperparameter in case you want to have an integer number, a float number, or even a string, okay? After that, we have also the minimum impurity decrease. This is also from the decision tree. We have the minimum impurity split, again from the decision tree. Now, the bootstrap is by default true. This is the bootstrapping and the bagging idea. Whether bootstrap samples are used when building trees or not. If false, the whole dataset is used to build each tree, okay? And then we have the OOB score, right? Whether to use out-of-bag samples to estimate the generalization accuracy or not, okay? It's by default false, but we used it in our implementation, okay? And this is very, very important. The number of jobs is very, very important. The number of jobs to run in parallel, because we have different decision trees that are running in parallel. So the number of jobs is used to optimize the solution and make it run even faster, okay? So this is from sklearn. And we have the random state. The random state is basically for making the randomness the same, or control the randomness of the bootstrapping and the sampling of the features, okay? So when you run the code again, you will get the same exact results. And verbose is for controlling the verbosity when fitting and predicting. Warm start, if you set this to true, right, it's by default false. Then reuse the solution of the previous call to fit and add more estimators to the ensemble. So what this will basically do is that if we run the fit function and then run the fit function again, then it will start from where it stopped, okay? So it will add more estimators instead of start from the very beginning. And we have the class weight. We know this also from the decision tree. And we have the CCB, right? The CCP alpha, right? This is for the pruning, because we can use pruning with the random forest, because the random forest are basically collections of decision trees. The maximum samples, this is if the bootstrap is true, the number of samples to draw from X to train each base estimator. So these are the attributes or the hyperparameters we have for the random forest. As you can see, almost 90 or 95% of them are coming from the decision tree. And the other 5% are the number of estimators, the OOB score, if we want to use bootstrapping or not, right? And the maximum features and the maximum samples for this random forest. So as we can see, we can perform the same hyperparameter tuning we did before, but we can also add the number of estimators and add the maximum features to see if we can get even better results. So this is a discussion or a brief description for all the hyperparameters we have. If you have any questions, as usual, you can ask me in the Q&A section or send me a DM. Now, let's go to the next lesson where we discuss the pros and the cons of the random forest. So let's go.